I've got a big, bad, beautiful electric truck with a massive 131 kilowatt hour battery. If the power goes out, it would be fantastic to use my truck to power the house in an emergency. When I'm not charging up my truck, my household energy use is actually pretty small. We only use 12 kilowatt hours of energy per day. So I could power my house theoretically for more than 10 days using the battery in the truck. But what do you actually do to get the energy out of the truck and into the house? Today I'm going to show you a few good, bad, and very ugly options, so at least you'll have a little bit of an idea of what you could do in an emergency. Like that. And I'm not just gonna focus on how to get the energy out of my truck. I've also got one of these portable power stations here, and a lot of this is also applicable if you have a gas generator. Heavy. So my Ford Lightning has a feature called Pro Power on Board. Many Ford trucks, electric or not, have this feature. There's different levels. I have the 7.2 kilowatt level, which is really good. It has 240 volt output, 30 amp. I've got a bunch of 120 volt, 20 amp outlets. They're in the front, they're in the main cabin, and they're out here in the bed. So of course, the easiest way to get power into your house in an emergency with this truck, you plug an extension cord into the back, you take this end, you fish it through a window, through an open door, and you plug your fridge in. You get your 4 different extension cords plugged in, you get all your different power strips going, you put them in the house, and it's gonna work. I just dread the day of having to pull my refrigerator back from the wall and fish around in there and plug it in. Ugh. But this is an actual really good viable option because each one of these cords can do 1200 watts. Each outlet can carry 2400 watts because it's 20 amp. You can power a ton of stuff in an emergency. For example, microwave, probably 1200 watts. Expensive La Marzocco coffee maker, probably 1200 watts. Portable air conditioner, probably 1200 watts. Every house is different, every appliance is different. If you want to actually figure out your draw for every little bit in your house, getting one of these little kilowatt devices is a nice place to start. And really, in an emergency, the devices you're gonna need the most, your phone, your computer, your Wi-Fi, those have a very small draw, probably less than 200 watts all combined. So that's the ugly way to do it, which is actually perfectly reasonable, safe, legal. Let's talk about the bad way to do it, which is discouraged, dangerous, and disallowed. And I want to show the bad before we get to the good, because I think it's a very solid learning step to kind of understand how home electrical systems work, at least in the United States. So we're going to build a nice little suicide cord today. So I've got a male extension cord with the pigtail already ready to go. Just got to strip these wires. And then I've got another male end, which is lighted as well. So we'll be able to tell if the juice is flowing. First safety precaution, put this plastic cap on. Safe, perfect now. We all know how an extension cord works, right? You plug this into a power source, and now this end has power, and it can distribute that power out to an appliance. This cord works the same way. You plug this end into a power source, and now all of a sudden there is power available. It's just coming out of a male plug, and if you touch it, it's gonna hurt. And this power station is a pretty good way to demonstrate this because I have the AC power turned off. I can safely plug in. No juice coming out of this side. And now I can hit the AC on and we can see we have juice coming out. We've got a bright green light. So this is where things get interesting, dangerous, and dynamic. Instead of having 4 different extension cords coming off the truck, coming off your Blue Eddy power station and plugged in to actual appliances, it is possible, but not recommended, to have this double male plug in to a circuit and you will be able to backfeed your panel. There's quite a few details here, so let's start with the basics. I'm turning off the garage circuit. All the lights are out, the power is down now. I've got my double dongus danger cord. I'm gonna plug one end into the Bluetti. AC output on the Bluetti is off. The light is off. We're safe. And now I'm plugging in to this receptacle, which is on the garage circuit. When I plug it in, there's no power. We are dead on this side and dead on this side. Now I'm gonna turn on the AC output on the Bluetti. After a second, the power comes back on. The Bluetti is putting out 162 watts to support all of the various things in the garage. I think the overhead lights are probably most of that wattage. So hopefully we're on the same page now about what is possible, but things are just going to get more complicated now. This Bluetti can put out 20 amps of power, but this circuit, the garage circuit, is only built, it's only rated for 15 amps of power. The wires in the wall are thin. These little cheapo outlets are probably just scraping by to support 15 amp. So if you happened to plug two portable air conditioners into this one receptacle and start running it for hours on end, there's a pretty good chance you would melt that receptacle. You could probably start a fire in the walls because now we bypassed that circuit breaker. We turned it off. We turned it into a dead end. It is not gonna bail us out now. If you just would have plugged those two portable air conditioning units into the Bluetti directly, you would have no problem. Well, the problem would be the Bluetti would run out of battery very, very quick compared to my truck. And we'll get back to my truck in a minute. I just have to go over a few more things before we get to that side of the problem. Backfeeding just one circuit is kind of a weird edge case scenario. I could see doing it if you wanted to take one circuit off grid and use a little smaller solar power system to just feed all the outlets in the garage. So I think the next step needs to be a more realistic backfeeding scenario where you're feeding more than just one circuit. But first, I need to update the design on my killer cord. I'm gonna do some modifications and hopefully make this a little more safe, make it into more of a portable generator inlet. It's pretty much the same thing, except for you've got a nice active safety panel. Okay, I'm gonna test the new inlet box. I've turned the garage outlets off. I've got my normal extension cord here. This one also lights up when there's power. No light. Plug it into the box. Ow! Plugged into the Bluetti. Now I'm going to turn on AC power, give it a second. Okay, back up and running. So now let's move on to a more realistic power just went out scenario. First thing, I'm going to go out to my main breaker, kill the power to the entire house. So we're still moving through the bad way to do this. In the good way to do this, you'll have a proper generator inlet and you'll have a generator interlock on your panel. So there's no way for you to backfeed the panel and backfeed the grid. So if the power goes out at your house and you plug in one of these DIY monstrosity cables, plug in your Bluetti, plug in your truck, you feed power back to your house. But if you don't break your connection with the grid, you are feeding power back to the grid, which means any lineman that is out trying to fix the power outage is going to get a horrible surprise when they feel that the lines are still live because you're sending 7.2 kilowatts back through the power lines. So when the power goes out and you want a whole home backup, you have to cut your connection with the grid. So my connection is cut. I'm going to turn off every single breaker in my sub panel as well. And now, if I turn on the Bluetti, once again, we are on our own little island. We're on our own little circuit. This is powering just the garage. Nothing is reaching back to anywhere else in the house. Okay, it's time to continue the experiment. How much more of the house can I power by just backfeeding one circuit? So now, all these circuits in the sub panel are turned off. I'm gonna turn the garage circuit back on. And now this sub panel is energized. I should be able to flip one of these breakers and send power to a different circuit. Let's try the microwave. Unfortunately, the microwave did not turn on. We've got no power to the microwave. And some of you may already know the reason. But if I flip the microwave off and I turn on the fridge, I heard a little click. The fridge is turning on. It's a hot day and we do not want these groceries to go to waste. So now that I've got the electrical panel cracked open, I've got the power off, I even pulled off some of the breakers to try to illustrate why an electrical panel behaves like it does. And you can see we've got two big thick wires coming in right here. Those are two different legs of split phase power. 120 volts coming in on black, 120 volts coming in on red. So let's imagine this is the black wire, this is the red wire, and inside the panel, we have these fingers that the breakers attach to. So if I'm feeding the garage through my pinky finger, all of these fingers will have power, but none of these fingers will. So the garage and the fridge are on this hand, and the microwave is over here, stranded, no power. So this row is on the same leg, this row is on a different leg, and alternating back and forth. And that's why when you have a 240 volt circuit, when you need both legs, they're right next to each other. So now you're probably thinking, maybe I should move all the critical loads in my panel over to just one leg, so if I backfeed the panel, I can actually get everything that's critical up and running in my house. And to that I say, let's not. Let's stop. Let's actually cut our losses, pull the plug, and start to do this the right way. So now it's finally time to get back to the truck. I'm gonna turn on Pro Power on board. I'm gonna hook up an extension cord in my bed, and I'm gonna plug it into this garage circuit. And look at that. Nothing happened. And now we can finally get to the heart of the matter here. The truck has ground fault protection. It is constantly monitoring all the current it sends out and all the current it receives back. So if there's any discrepancy between those two things, it can immediately cut off the power and be like, something's gone wrong, shut it down. So that's what just happened when I plugged the extension cord into my little box, into the house, boom, cut off immediately. And please forgive me for being very simple and trying to make this as digestible as possible. I had 5 different versions where I actually spend 10 minutes talking about the entire electrical system in the house. I think I can do this and keep it simple without having to go down every single rabbit hole. So the problem is the house, like every properly wired house in America, has a ground and neutral bond. But the truck also has a ground and neutral bond. The main purpose of a ground wire, which is usually attached to the old third prong of a plug like this right here, is to act as a safety superhighway. So any weird electrical charge can go back to the panel, trip a breaker, cause a fault. So let's imagine you have a fridge that is old school. It has a hot wire and a neutral wire. That's it, no grounding. And one day the compressor goes out, so you open everything up, you get the part on eBay, you fix it, you're feeling so good. But when you go back in to push all those wires into that small little thing, you nick the insulation on the hot wire. And now the hot wire is exposed. And when it gets pushed in there, it's resting along the metal casing of the entire refrigerator. You plug in the fridge, you hear it click on, it must be working. You grab, you touch the handle to open it up, and it starts shocking you so much you can't let go of the handle. You are dead. With an ungrounded device, you only need one silly mistake to happen for there to be a terrible accident. But if the fridge was properly grounded in that same scenario, every time you tried to turn it on, it would trip a breaker. You'd just get frustrated like, I don't know what the heck is going on. I thought I fixed it, I didn't fix it. A real electrician would have to come in and figure it out. There are still 10 million ways where electricity can hurt you, kill you, or burn your house down. But having proper grounding at least takes care of a lot of stupid mistakes where that first mistake would have killed you. Instead, you have to make 2 stupid mistakes. Okay, back to the truck. So the truck has the neutral and ground bonded together, much like a house has the neutral and ground bonded together for safety. So let's imagine the truck is plugged into the house. I'm trying to power it up. I'm sending current from the truck on the hot wire into the main panel of the house. From the panel, it goes and finds an electrical outlet where a fan is plugged in. Current keeps flowing on the hot wire to the fan gets powered up, and then the current has to flow back to the source from whence it came. Current comes back to the panel on the neutral wire, but Once it hits the panel, the neutral and ground are bonded. So then current starts flowing on the neutral back to the truck, and it starts flowing on the ground back to the truck at the same time. And then the truck's like, what? Shuts down the power, and here we are. So now for the truck to actually properly power my house, I have to be able to switch the neutral, get off of my house neutral and just use the truck neutral. We want to avoid that neutral ground bond at the house. So the solution is a generator transfer switch that not only switches the power source over, but also switches the neutral. This is the 30 amp home link, and the most important part is that it is compatible with GFCI generators, my truck. So my plan is to install the generator transfer switch right about here, which means I'm gonna have to take off this wood, get in here, connect the dots. But here's where the little 2-day, moderately expensive project turns into a 2-week money pit fiasco. The electrical code says that wood is not a proper barrier between the interior of the garage and the house. You need to have the studs, then drywall, then whatever you want on top of that. Getting everything out of the garage and tearing apart the walls was not that bad. Destruction is always easier than construction. And now that the wall is busted open, I've got a massive checklist of all these various things I want to fix and make right while I have it. A nice giant can of worms, as I knew it would be. And now, after about 100 hours of side quests, I am ready to move on to the main event. But first, let me tell you a little bit about what I've been doing for the past couple weeks. My big screen TV is mounted right on the other side of this wall, and previously I cut a couple holes in the drywall so I could hide the cables, the power, the HDMI. You're not supposed to have a power cord go through the wall like that, dangling through, so I installed a fresh new outlet up here. I can plug the TV in directly, and then, since we're on an exterior wall into the garage, I had to do a whole Smurf tube thing to keep this whole thing isolated and sealed. I got very lucky that all of these boxes were just about a 2x4 width away from the existing studs, so I did not have to do too much work to drill in this box. I tried all kinds of other stuff, failed, put holes in the wall where I shouldn't have, so it's going to take me a while to recover from those bumbling mistakes. I also did the same thing for my Ethernet run, Smurf tube, box, sealed. And then I moved my 50 amp EV charger plug from here about 5 feet closer to the garage. Previously, I had to stretch my cable a little too far. I was always worried about the Amazon delivery drivers tripping over the cable, breaking something in the charger. I didn't want to do it, but I spent like $300 on all the equipment. Like the cable is so expensive, the Romex, to move it, to put it in the right place, to have a little more slack in the line. And then I spent a lot of time in my panel tracing out every single circuit, labeling everything, drawing out a diagram because I have to pick the 8 critical loads I'm going to move out. I set up new dedicated circuits for the crawl space, for the attic. I merged my kitchen lights. My kitchen lights were on 2 or 3 different circuits, so I've got them on one circuit. Just a lot of little tiny improvements that added up to tons of work. So now we begin the puzzle of all puzzles. I have to pick the 8 circuits that I want to use for backup power. When the power goes out, I hook up my truck. Those 8 circuits are still going to turn on. And then I have to figure out how to get those circuits into the generator inlet panel. Luckily, the backup panel comes with a bunch of pre-terminated wire. I just have to get it to the junction box here, or some of it is going to go into the panel because some of these wires are too short. I have to meet them halfway, full way, part way, up way, down way. For example, the refrigerator, a very vital thing to back up in a power outage. These are the wires that go to the power outlet for the refrigerator. They would normally be hooked in to the panel here and get powered up. But I'm going to disconnect them from this panel, and I'm going to run wires all the way to the new generator backup panel where They will be powered 24/7 normally, but then when the power goes out, I plug in the truck, I switch over, and then this is one of 8 circuits that I'm deciding to back up power. I've got my 8 critical load circuits picked out. I've also got a sunburn and 6 pounds of sand up my nose right now because I just got back from Maui. I've also got the spot picked out where I'm going to mount this generator inlet box. This is where the extension cord from the truck gets plugged into, and then I'm running the 10-4 Romex that goes from this box over through the walls and into the backup panel. I've got everything strapped in and strapped up. I've got fire blocking, good to go. Now I'm putting all the insulation back into the wall cavities, and it's time for the main event, putting up the drywall. The drywall is so awkward and heavy, so I use some 2x4s to help me put stuff up all by myself. Shoot in a bunch of screws. Also, make sure I got all my measurements right for the holes I have to cut out of the drywall to make sure the plugs and various things work right. I'm on to drywall finishing now, taping and mudding, and this is just so tough beyond my understanding. I don't know what I'm doing wrong. Too much, too little, the screws aren't deep enough, just a million little things to make this just feel horrible. And hopefully some way I will be able to disguise this after, because I know if you just paint it, it's all the little stuff underneath shows up on the outside. It is the garage. I'm not too worried about it, but painful. And now, after suffering through the worst mud and tape job that you'll ever see, got my sanding done, it's time to add some PVA primer, and I am actually blown away how good this looks when you don't look very close. I will now listen to all the advice. I've learned my lesson. Do not DIY drywall. Pay an artisan expert to do it. 22 minutes into this video, 22 weeks trapped inside of this project. I need to get this done. I need to get this video out. I need you to hit the like button. I'm absolutely begging you at this point. You've made it this far. I'm gonna deliver. This is going to be fixed here any minute now. Also, got a new Klein screwdriver that I absolutely love, and it has the ECX type, which has the square and then the flat that's for outlets. Quick swap, magnet, and then it also has like a ratcheting effect. It's always annoying doing your own electrical stuff, trying to do it right, and then never having the right screwdriver. This is for my EV charging plug, and I actually got the proper Hubble receptacle that has the EV charger mark on it. Normal 50 amp outlets are just not made to go all day and all night. Now I can finally get the generator inlet box up and running. I've got wood blocking here, so anywhere I screw in, it'll be good. Got the knockout, I've got the bushing. Let's do it. Go, baby, go. And there it shall be till the end of time. The devil's tongue. Okay, wired up now. I need to get a big wire nut for this ground. There's a lot of room in here, hiding spot. Okay, mounting the monster on the wall. This should be pretty easy. Whoa. Just like I planned it. Okay. Don't come in, I'm busy. Oh, we need a new TV. Can I do that? Yeah. Okay, I added some washers to give it a lot more holding power. Now the real pain begins. Screwdriver rules. You can also put it in the center so it doesn't ratchet. And compared to the other Klein screwdriver that I've been using for quite a while, when you open it up, a lot of times these little bits just like fly out and spray out. This one's holding kind of strong, but my other one is just like, every time I open it, they fly out. Thumbnail? I am almost ready to start wiring everything up, but first I need to give the wires a clean and safe path back to the panel. This was a tough puzzle for me to figure out, but I think I have it. I've got all the proper conduit piping, junction box. I'm gonna add one of these conduit bodies. Previously, you may have seen I had a conduit body rigged up and I thought that would be good, but because it has a backside that is open, I would have had to cut a hole in the wall on the other side so this was accessible. So no, it's not gonna work. So instead I got a big old junction box here, put this on, bing, bang, boom! Perfect, just like I planned it. Man, I'm really not sure if I should be doing this all at once, just jam all the wires in. Yeah, maybe that's what I should do. Oh yeah. All right, we're past the point of no return. The power is off. I got the Blue Eddy backing up the lights here. I gotta get this done. The wife is out for a couple hours. These wires did all come labeled, so I'm gonna try to stick to the labels as much as possible. Damn, that's nice. Never thought I'd make it this far. We are so close to the finish line now. I've got the wires wired into the panel. I'm doing my multimeter testing, turning everything back on slowly but surely. Oh yeah. Good. All right, it's time for the real deal test. I read the manual. I think I have the correct mode engaged. Now let's fire up the truck, see what happens. I did everything right. There's no reason to be nervous. Ooh, the truck is powering the house. Yeehaw, let's see how much power it's using. 350 watts. I think the truck could go for a very, very long time. I messed up my initial testing because I didn't turn off the power to the house entirely. I didn't disconnect from the grid. The house is humming along right now. The fridge is on, lights are on, the internet is up and running. I'm right around 500 watts. Let's say I'm running that 500 watts for 24 hours. That ends up with 12,000 watt hours, 12 kilowatt hours. And remember, in the beginning of the video, I think I said my house averages only 14 kilowatt hours per day when I'm not charging my truck. So the truck has a 131 kilowatt hour battery pack, and it's at 89% right now. So if I multiply 131 times 0.89, I get 116 and a half kilowatt hours remaining. Divide that number by 12, which is how much I'm using every single day, and I get 9.7. 10 days of backup power. And of course, things fluctuate up and down. If my wife turns on the espresso machine, that's 1,200 watts of power, but you know, maybe 5 minutes is all it's using. I am ready for a victory lap. I've got everything back in the garage, except for maybe one or two little things outside. You can hardly recognize the place. The one thing I did skip, and I hope I don't regret it, is doing a full-on load test through the truck, through the panel. I've done some pretty big wattage through the truck before, so it can handle it. I'm positive. I don't even think we have enough heavy-duty devices to get up to that 7.2 kilowatts that the truck can put out. Oh man, as this project drug on for days and weeks and months, I was so paranoid there was gonna be some big earthquake and I'm not gonna have the project done. I guess I could have used the extension cords from the truck and it all would have worked out. But to have like a one button push, hey, we're backed up, we're good. Everybody in the neighborhood, come by, charge your phone. Oh, I don't really consider myself a prepper, but the idea of self-reliance is very, very romantic to me. And I would love for this to just be the first step along the path of being able to be my own power plant, run my truck on my own electricity, all that good stuff. And in the next video, which will be out sooner. I'm not gonna take 3 months between videos anymore. I'm getting down. I'm gonna get these videos out. The next video, I've got some solar panels. I'm gonna figure out a way to hopefully do it on the cheap and hopefully save some money, but I won't know until I get it going. So I'm gonna get it going. Thanks for being here. I hope you return again. I've got so many different things I wanna do to this house and I gotta get going.